In this video, we'll be looking at the graphs of the sine and cosine functions. So first, let's look at the sine function. What we have here is the parent function for sine of x. And I'll highlight a few of the important characteristics of the parent function for sine. So we notice that the maximum value, well, before I say that, what we notice is that the curve is touching the same maximum value and minimum value, and it keeps bouncing back and forth between those max and mins. What we say is that this graph is periodic. All of the trig functions have periodic graphs. What that means is the graph cycles through the same path as the x values increase. And the maximum value and the minimum value for the parent function is always 1 and -1. So the graph is always bouncing between positive and -1. Now, the sine graph starts at 0. I mean, it doesn't really have a beginning and an ending, but if we were to take a snapshot, we would say this can start at 0, and once it reaches 2 pi, the graph starts to repeat itself, right? So at 0, it's increasing. After 2 pi, it's increasing again. So this distance between 0 and 2 pi, we say is the period length. Okay? Now, if we were, which is 2 pi, the period length. Now, anywhere we are on the sine graph, if we take a snapshot or a slice of an interval that is 2 pi in length, we will get one complete cycle or one complete period of that graph. So if 2 pi, if we're starting at 0 and ending at 2 pi, what we notice is that the sine graph crosses 0 at the beginning, it crosses halfway, and then at the end of that period. So this is important. Crosses 0 at beginning, middle, and end. And then the maximum value is up here. The minimum value is down here. So this point, pi over 2, is 1/4 of the way within the period. And 3 pi over 2, which is the minimum value, is 3/4 of the way. So we call these points the quarter points. So we would say max and min at the quarter points. And then the last thing I want to mention is how the values on the sine graph relate to what we see on the unit circle. So let's say we have x and then sine of x. So we have the input, x, and then the output, sine of x. So if we're thinking about angle measurements in radians, when we start going around the unit circle, we would say 0, then pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. So that is everything from quadrant 1 and 2. Now I'll fill out the sine of x values. So what we notice is that from 0 to pi over 2, this is when the sine graph is increasing, right? We have 1/2, root 2 over 2, root 3 over 2, then 1. And then from 1, or the next half, from pi over 2 to pi, it's decreasing. And this corresponds to what we see on the graph. At 0, we have 0, and then we're going to increase until we hit pi over 2, at which point the output value is 1, and then we decrease down to pi. Okay, So if we were to continue writing out these angle measures, we would see that the sine graph is going to decrease until 3 pi over 2, which on the unit circle is this value right here, right? The output value is -1 at 3 pi over 2, and then it returns back to 0 at 2 pi. So we can think of a trig graph as though we're kind of unspooling or unwinding the unit circle. So next, let's look at the cosine graph. And again, cosine is periodic. It's bouncing between -1 and +1. Now, notice this is different because first of all, let's say what the period length is. Period length is 2 pi. And at the beginning of the period, we have the max value. And then at the end of the period, we reach the max value again. In the middle, at pi, we have the minimum value. And then in this case, at the quarter marks is when we hit 0. So we're going to say max and min at beginning, middle, and end, and then 0 at the quarter points. So it's the opposite of what we see with the sine graph. And let's think about how this relates to what we have in the unit circle. I'm going to give the exact same angle measures for x. So we see the angle measures for x for the top half of the unit circle and then the corresponding function values. And what we see is between 0 and pi over 2, now this cosine graph is decreasing. And then from pi over 2 to pi, the value of the function is increasing. So that corresponds to what we see. From 0 to pi over 2, from 0, hang on. I need to add negative values here. Okay, so 2 pi over 3 is -1/2, and so on, so negative values. All right, so from 0 to pi over 2, from this part, the value of the function is decreasing. From pi over 2 to pi, it continues to decrease, but now we're negative. We get down to the minimum value of -1. If we were to continue on in quadrant 3 and quadrant 4, cosine, it would stay negative for quadrant 3, and then in quadrant 4, it would become positive and continue to increase. Okay? So again, it's kind of as though we're unwinding the unit circle to get this trig graph. So let's discuss how we can come up with a graph for sine and cosine if it has any transformations, so it's shifted left, right, up, down, any vertical or horizontal stretch or shrink. So we'll follow these steps. So first, we'll write the equation in standard form. And what we have right here is the form we want to see. Okay, so y equals a sine times b x minus c plus d. So we want to find the amplitude, the period, and any vertical and horizontal shifts. So the amplitude corresponds to the a value, and it's actually the absolute value of the a value. And the a value is just from the standard form of the equation. The period length, that's going to be 2 pi divided by whatever the b value is. Now, what we saw here, the period length was 2 pi. The b value corresponds to a horizontal stretch or shrink. So we're going to take the initial standard period length, 2 pi, and then we're going to divide it by b, and that will account for a horizontal stretch or shrink. And then we're going to apply any vertical or horizontal shifts. So just like we saw in regular algebraic functions, the c value here corresponds to a horizontal shift, and the d value corresponds to a vertical shift. Okay, then we divide the period into 4 equal parts, and then we apply any horizontal shifts. So we'll discuss this more. This is easier to see when we have an actual example. Determine the 5 key points on the graph. So back to the cosine graph. The key points were the maximums and the minimums, and then wherever it crosses the x-axis. So those red points are the 5 key points. Similarly for the sine graph, these 5 points are the 5 key points we want to identify. So we want to see wherever the max and mins are and wherever it crosses the x-axis. So first, for a sine graph, crosses the horizontal axis at the beginning, middle, and end, and has max and min values at the quarter points of the period. And then cosine is the opposite, where it crosses the horizontal axis at the quarter points and has max and min values at the beginning, middle, and end. All right, so once we map out what the period looks like, we apply any vertical shifts to the 5 key points. The new midline is this, and then we sketch a graph. So what follows in the video are 4 different examples, and we'll go through these steps for each of those examples. All right, so let's graph y equals 2 sine, I'm going to write 4x in parentheses, plus 1. So we want to write this in the standard form. The standard form is y is equal to a sine b x minus c plus d. Okay, so what we want to do is anytime we have a coefficient on x, we want to factor it out. So y is equal to 2 sine 4 x minus 0 plus 1. So we want to write it like this so that we can explicitly see what the c value is and what the d value is. And if you multiply this out, we're going to get to what we started with. So let's just go through. We want to find the amplitude. The amplitude is the absolute value of the a value. So absolute value of 2, which is 2. The period length is 2 pi divided by the b value. B value here is 4, so 2 pi divided by 4. So simplifying that, we get pi over 2. Okay. Horizontal shift, that corresponds to the c value. So because it's 0, we have no horizontal shift. The vertical shift corresponds to the d value. And because it's positive 1, we're going to say it moves up 1 unit. Now it's very important that you say whether we're moving up, down, left, or right. Do not do this. Don't say plus 1 for the vertical shift, because the vertical shift, it does correspond to what the sign is. So if it's positive, we're moving up. If it's negative, we're moving down. But the horizontal shift is not like that. If we have a negative c value, we're moving to the right. If it's positive, we're moving to the left. So I want you to be explicit and say up, down, left, or right. Looking back here, so we found all of this stuff. Now we're going to divide the period into 4 equal parts and apply any horizontal shifts. So the period length is pi over 2. So what I'm going to do is I'm going to write a number line, and I'm going to put 0 at the beginning, pi over 2 at the end, because that's the period length. And then what I'm going to do is I'm going to cut it in half and then cut each half in half. So I've gotten 4 equal sections. So to figure out the halfway point, I just take the end of the period, pi over 2, and multiply it by 1/2. I end up with pi over 4. To find this value, I take pi over 4 and multiply that by 1/2, pi over 8. And then this one right here is the challenging one. What you can do is add these two. The problem is you'll need a common denominator. So pi over 8 plus 2 pi over 8 is 3 pi over 8. Okay, so we've mapped out one period length. Since there's no horizontal shift, I don't need to do anything else. So what I'm going to do is on the graph, I'm going to map this out. So 0 is right here. And I'm just going to go 2, 4, 6. So I'm going to put pi over 2 right here. And then I'm just going to label all of these tick marks. Pi over 8, pi over 4, 3 pi over 8. Okay, and then the vertical shift is, so if there was no vertical shift, the graph would be going like this. Okay, this is assuming there's no vertical shift. The amplitude is 2. That means I'm going up to a maximum value of 2, down to a value of negative 2. Remember, sine cross at the beginning, the middle, and the end, and then at the quarter points is when we have the max and mins. However, there is a vertical shift, so I need to shift this entire graph up 1 unit. So I'll do it in a different color. So the graph now is, the horizontal scale is staying the same, but I'm going to cross here, here, and here. I think my scale is, yeah. So this value is the new midline. It's the new line that is going to cut through the middle of the graph. So y is equal to 1. Everything is shifting up 1 because it's up 1 unit. Okay. So from that line, y equals 1, I'm going to go up 2 units and down 2 units. And that's going to account for the amplitude. Okay. So sine crosses at the beginning, the middle, and the end. And then the maximum value and the minimum value are at the quarter points. So this graph is going to look like that. So the green graph is what we want. Y is equal to 2 sine 4x plus 1. So sorry if it's a little bit messy because I had the blue graph in there, but it's good to see how the transformations work. One thing I have not mentioned is that if there was a negative coefficient on the initial graph, well, think back to regular transformations. A negative leading coefficient gives a vertical reflection. So if the leading coefficient was negative 2, this graph would be decreasing first instead of increasing. And we'll see one of the examples has that. All right, next example, we have y is equal to negative cosine of 2x minus pi. So we want to write this into the standard form. Sorry, my pen is having some difficulties. So y is equal to a cosine b of times x minus c plus d. So we want to factor out whatever coefficient we have on the x. So we're going to end up with y is equal to this negative. I'm going to write explicitly that the a value is negative 1. Cosine. So we factor out whatever the coefficient is for x, which is 2. Now, when I factor out a 2 for each of those two terms, I just divide each term by 2. So 2x divided by 2 is x. Pi divided by 2 is pi over 2. And then there's no d value, so there's no vertical shift. All right, so the amplitude here is going to be the absolute value of a, which is absolute value of negative 1, so 1. And that negative means we're going to have a vertical reflection. The period length is 2 pi divided by b. The b value here is 2. So the period length is pi. And for the horizontal shift, we are going to go right pi over 2 units. Again, make sure you say explicitly right pi over 2. Don't say plus pi over 2 or negative pi over 2. You need to say right or left. in this case right. There's no vertical shift because the d value is 0. All right, now comes the difficult part. So I'm going to map out the period length on a number line. So we're starting at 0, we're ending at pi, and then divide this into 4 equal sections. So divide pi by 2, we get pi over 2. Divide pi over 2 again by 2, so pi over 2 times 1/2 is pi over 4. And then add these two together. Pi over 4 plus 2 pi over 4 gives 3 pi over 4. All right, now that we have that initial period length and all marked off, what we need to do is, because there's a horizontal shift of pi over 2, we need to add pi over 2 to each of these values. So if you're a little rusty with fractions, this is when you're going to start paying for it. Okay, so I'm going to add pi over 2 to each of these values that I marked off. So 0 plus pi over 2, that one's easy. That one's pi over 2. Pi over 2 plus pi over 2 in the middle, well, that's just pi. Okay, so it might be good to get some common denominators. Pi is 2 pi over 2. So 2 pi over 2 plus pi over 2 is 3 pi over 2. We could also rewrite pi over 2 as 2 pi over 4 to add to the quarter points. So pi over 4 plus 2 pi over 4 is 3 pi over 4. 3 pi over 4 plus 2 pi over 4 is 5 pi over 4. So this is the most vital part of these types of questions, is being able to remap the period length and account for any horizontal shifts. So if you don't get this, keep retrying this until you can get this correct. Okay, so let's graph this out. So I'm going to mark off the period length, which is here. So we're starting at pi over 2, we're ending at 3 pi over 2. It's kind of arbitrary where we start here. I typically, on this grid, I always make each section worth 2 boxes. 2, 4, 6, 8. Okay, so pi over 2. Okay, the amplitude is 1, so that means the graph is going to be bouncing between 1 and -1, and since there's no vertical shift, I don't need to adjust the 1 and -1. The graph is going to be bouncing between those two. And remember, cosine, it hits the horizontal axis, which is here, at the quarter points. So the graph is going to hit here and here, and then the max and mins are at the other values. Now, because the leading coefficient is negative, that means instead of beginning up here, the graph is going to begin down here. So the graph is going to go like this, and then at pi we're going to have the maximum value, and then it's going to come back down to the minimum value. So that is one period length for this graph. Something that I failed to do on the last one, but I'll do it here. We want to discuss what the domain and range are for these graphs. So the domain and range the domain for any sine or cosine function is all real numbers. The graph continues going to the left and to the right forever. The graph just keeps bouncing back and forth. Something like, you get the idea. The range, though, we want to see whatever we're bouncing between on the max and the min values. So the smallest value that the function hits is -1. The greatest value is 1. So the range here is going to be -1 to 1. And we include those values because the graph actually passes through -1 and 1. All right, the next one, y equals 3 cosine of x plus pi over 2 minus 1. Writing this in the standard form, because there's no coefficient on x, it's just a 1. I can factor out a 1. You don't need to factor out the 1, but it's just to be explicit what the b value is. So the amplitude here is absolute value of 3, which is 3. The period length is 2 pi over the b value. So just 2 pi, the b value is 1. We're going left pi over 2 units. That's coming from this. And then we're going down 1 unit. Okay, so to map out the period length, we're going to go from 0 to 2 pi. And then split it up into fourths. The middle value is half of 2 pi, so that's pi. This value here is half of pi, which is pi over 2. And then I want to add these two together. Pi over 2, I can rewrite pi as 2 pi over 2. So that's 3 pi over 2. Just make this pi. All right, and then because we're shifting left pi over 2 units, what I want to do to get to the new number line is I want to add pi over 2 to each of these values. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is pi. I could rewrite pi as 2 pi over 2. I guess I shouldn't have erased it. So 2 pi over 2 plus pi over 2 is 3 pi over 2. 3 pi over 2 plus pi over 2 is 4 pi over 2, which is 2 pi. And then 2 pi plus pi over 2, that's the same thing as 4 pi over 2, so 5 pi over 2. These are the new values we want to work with. Okay, mapping it all out. So the amplitude is 3 here, so I'll make each box worth 1. However, I'm shifting everything down 1 unit. So instead of going up to positive 3, I'm going to be going up to 2 and down to negative 4. So 2, negative 4. And so the new midline is going to be y is equal to negative 1. Okay, so recall that a cosine graph hits the midline. Remember, the midline is moved down too, so it's going to hit that midline at the quarter points, and then the max and mins are at the beginning, middle, and end. So the maximum value now is 2, and the minimum value is negative 4. We start in the positive, or the maximum value, because there is no vertical reflection. So we're going to start at 2. At 3 pi over 2, we're going to go down to negative 4. And then we're going to increase back up to at 5 pi over 2 to 2. So the graph looks something like that. Okay, so for the domain, as mentioned, it's always all real numbers. For the range, the smallest value we get for the function is negative 4. The greatest value is 2, and we include those endpoints. All right, and then one last example. Y is equal to negative 5 sine of x minus 4. Writing this in standard form. There's no coefficient on x, so we can factor out a 1. There's no c value, so we could rewrite it like this. So the amplitude is going to be the absolute value of 5, or negative 5 rather. Okay? Because the leading coefficient is negative, this means there's a vertical reflection. We're going to start by decreasing on the graph. The period length is 2 pi over b. The b value is 1, so we just end up with 2 pi. There's no horizontal shift because it has a c value of 0, so we'd say none. Vertical shift, we're going to say down 4 units. Okay, so mapping out the period length is 2 pi. middle is not 0, it's pi. Half of that is, it's getting late. The half of that is pi over 2. This is 3 pi over 2. Since there's no horizontal shift, we don't need to add or subtract anything to this period length. So we can go ahead and draw this number line onto the graph. Okay, so we're going to start at 0 and then checking off the quarter points. Okay, the amplitude here is 5, so we're going to be going up to 5, down to -5. The issue though is we have a vertical shift down 4 units. So instead of going up to 5, we're going to go up 4 less than 5, so only up to 1. And then -5 minus 4, we're going to go down to -9. And instead of a midline of y is equal to 0, the new midline is going to be at y is equal to -4. Okay, so that's the line that the graph is going to be revolving around. Okay, so sine crosses the midline at the beginning, middle, and end. And then the max and the min values are at the quarter points. Now, typically a sine graph would be starting like this. However, because there's a vertical reflection, the graph is going to be starting by decreasing. So the graph starts at -4, goes down to -9, back to the midline, up at 3 pi over 2, it's going to hit the maximum value, and then we're back to the midline. So the graph is going to look something like this. Okay, so the domain again is all real numbers. The range is everything between -9 and +1.